Hello and welcome back. We're in the middle of our unit on circles, and we've talked about things that are inside the circle, and we've talked about things that are outside the circle. And today we're talking about things that are coming through the circle. We're introducing the term secants today. You ready? Here we go. A line that intersects a circle in exactly 2 points is called a secant. And the measures of angles formed by secants and tangents are related to the intercepted arcs. Okay, so PQ and RS are secants. Not to be confused with chords. Chords stop on the circle. Secants go through the circle. If two secants, or chords, intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. That's a mouthful. Okay, let me show you what that means. Here's angle 1. And the measure of angle 1 is 1/2 the sum of the intercepted arcs. So 1/2 of PR plus QS. Let's do an example. Okay, we need to find X. Right, well, there it is. But let's find the measure of angle X. So the measure of angle X is 1/2 the sum of its intercepted arcs. So 1/2 of 30 plus 55, 1/2 of 85, which is 42.5. All right, now if a secant, or chord, and a tangent intersect at the point of tangency, that's just on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So here's the point of tangency, and the measure of XTV here is just 1/2 the measure of its intercepted arc, the arc of TUV. The measure of angle YTV is 1/2 of its intercepted arc, TV. So on this one, if we want to find the measure of angle Y, we just have to take 1/2 of its intercepted arc of 168, which is 84. If we want to find the measure of angle 3, we just have to take 1/2 of its intercepted arc. But there's no measurement there. But we can find the measurement by taking 360 minus 216, the rest of the circle. So we know that its intercepted arc is 144, and 1/2 of 144 is 72. Now, if two secants, a secant and a tangent, or two tangents, intersect in the exterior of a circle. So we've done the interior, we've done on the circle. Now we're in the exterior of a circle. Then the measure of the angle formed is 1/2 of the difference of the measures of the intercepted arcs. Let me show you what I mean. We're going to find the measure of MPN, that little guy right there. And it's 1/2 the measure of the difference of the intercepted arcs. So 1/2 of 34 minus 18, which is 8. Let's try another one. The measure of angle R is, well, 1/2 the difference of its intercepted arcs. We know one of them, 62, but we don't know the other intercepted arc. But again, we can find it by taking 360 minus the measures that we do have, 116 and 62. And we know that the other intercepted arc is 182. So the measure of angle R is 1/2 of 182 minus 62, which is 60. Okay, one more. This time, we're going to find the measure of an arc, given the measure of an angle, 52 here. So we want to find the measure of CE. Well, let's just call that X. That's one of the intercepted arcs. The other intercepted arc is 360 minus X. So to find X, here's what we do. We know that 1/2, the difference of the big arc minus the little arc, equals 52. And we solve for X. So X equals 128. So to sum it up, if two secants, a tangent and a secant, or two tangents intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measures of the intercepted arcs. If they meet at the point of tangency, then the measure of the angle formed is just 1/2 the intercepted arc. If they meet in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So in this lesson, you just have to figure out where the two lines intersect, inside, on, or outside. Then you know the relationship. Thanks for being here.